going to go ahead and look at an example. This is on page 92 of your textbook. This is an application. So we have a box of cereal that is supposed to weigh 13.8 ounces. So that's our goal, 13.8 ounces. But it's acceptable for the box to weigh or to vary as much as 0.1 ounces. So that means when we have a box of cereal, for example, our box of cereal right here is 13.9 ounces. We want the variance to be no more than 0.1 ounces. So how can we represent that? How can we talk about that variance mathematically? So one way to describe the variance would be to subtract these two values. And we know that whenever we subtract them, we could either be like a little bit over or we could be a little bit under. So we want it to be between, we want it to be no greater, whether it's a little bit over or a little bit under, we don't ever want it to be bigger than this amount. So let's think about how we could represent that. So if we were to subtract these values, we would get a difference of 0.1, right? 0.1 ounces. So that's within our range, right? And how we'll represent this is we'll take the absolute value of our difference, because that will always ensure that our difference, whether it's a little bit over or if it's a little bit under, it will always be positive, right? Because we know we take the absolute value of a number, we get a positive for our output. Okay, so let's just see if this works. We have 13.9 ounces minus our 13.8. We know that's 0.1 ounces. So that would satisfy our equation. We know we want to be no greater than, so less than or equal to 0.1 ounces. That is our goal, right? This is our ideal box of cereal, but we want our weight variance to be no more than 0.1 ounces. So this works. We take the absolute value of 0.1 and we are satisfying this equation. So let's go ahead and try another box of cereal. We have our 13.77 ounces and we have our ideal weight here of 13.8. So if we take the difference of those, we're going to get negative 0.022. So we're just like barely a little bit under, like I got a few more whatever cereal in there than the previous box, and that's okay. So we take the absolute value of this. We know that amount is still going to be less than, or it's definitely not equal, but it'll be less than that 0.1 ounces. So we represent the range by using our absolute value, and that ensures that whatever we have as a difference is not going to be greater than this amount. So that absolute value will turn those negatives into that positive, and it'll ensure that we're in the right range. Okay, so this means that we're going to have, this is always going to be our variance. So how much we're allowed to vary. And so if we're going to go ahead and write this as an actual equation, we'll represent our box of cereal. We'll put just like any box of cereal in there. So W, we call it. Any weight, we're not sure which box it is, but we know that it's going to be just W amount. And then we subtract our goal of 13.8. We know that that always has to be between no greater than a variance of 0.1. So I'm going to go ahead and write that as an equation. So we have absolute value of W minus 13.8. And that's going to be no greater than 0.1 ounces. Okay, so remember, this is our goal. This is our just whatever box of cereal we're testing. And what we can do is solve this, and we'll have a range of acceptable weights. And after you solve a couple of these, you might already kind of notice a pattern. But we're going to go ahead and solve it out in case you don't see any patterns yet. I always encourage you to look for patterns. So we're going to have the negative end over here. So that will be, we're now going to change the sign. So it'll be greater than or equal to, go ahead and highlight that again. And we can solve from here. So add 13.8. So we have a box of cereal that's no greater than, or I'm sorry, that's less than 13.8. And then here, I have 13.8. Our box of cereal will be greater than 13.7. And so let's think about this. Do we have a box of cereal that can be greater than 13.7 but less than 13.9? And the answer is yes. That's going to be one of our situations that is an and, because we can have a box of cereal that lots of box of cereals that could be within those two parameters. So remember, we think of it as between. So our weight can be between 13.7 ounces and 13.9 ounces. So this would be how we could represent all of the possible values of our box of cereal that could be no greater than this variance of 0.1 from our goal of 13.